Curve has the equation y equals f of x given by this pretty complicated function. X has to be greater than ln cube root of 2. That's to ensure that the function inside the square root is positive. It can't be negative because then you couldn't take the square root for the real number. It can't even be 0 because then we'd be dividing by 0. It doesn't actually come into this question other than that. So we're then asked to differentiate this function essentially, but write it in a very specific way. Okay, I'm going to do it down here. I need a bit of room. Let's do this. Going to use the quotient rule. I've got u divided by v, and the quotient rule is u dash v minus u v dash over v squared. To find u dash, I'm going to actually use the product rule, but I'm not going to start writing more u's and v's down. I'm just going to take the 7x as one of my functions and e to the x as the other. So differentiate the 7x and times by e to the x, and then take 7x and differentiate e to the x and times by that. So that's my u dash. Sometimes if you start writing all the formula down, it can actually just make it messier. And then v dash, I'm going to use the chain rule. Right, first I'm going to write it as e to the 3x minus 2 all to the half. Okay, and I'm going to use the inside-outside version of the chain rule. So differentiate the outside, it's something to the power of a half, so it becomes a half of that. E to the 3x minus 2 to the minus a half. And then I times by the derivative of the inside, which is 3e to the 3x. Got to be said, I think this is the hardest part of the question because, well, the part A, the whole question, because there's so many places you can just make a little mistake. The good news is that if you do make a mistake, you can just still carry on with the rest of the question, come back to it. Okay, I wouldn't spend a long time finding out one sign error or something like that. If you might have just missed something out. Just keep up the pace, especially at this very last question. All right, let's substitute in. So u dash. Now I can see in my final answer we factorized out a 7e to the x. I'm actually going to do that here. Look at 7e to the x, 1 plus x. That's my u dash, and I'm timesing by v. I'll rewrite it with the square root e to the 3x minus 2. And I'm minusing u, which is 7x e to the x, multiplied by v dash, which becomes 3 over 2 e to the 3x. And I'll times it by 1 over the square root of e to the 3x minus 2. And then this is all over b squared. Actually, that becomes e to the 3x minus 2. It's just a bit of work now to get it in the right kind of form. Now, the first thing I'm going to do is multiply through by the square root of e to the 3x minus 2, because I can see in my final answer that that's what I've got here. I'm also going to multiply top and bottom. When I say through, I mean top and bottom, not like just the top. And then I'm also going to times top and bottom by 2. I think I'll do this all in one go. So I'll get, I'm going to keep the 7e to the x because I can see that in my final answer. Then I'll get 2 plus 2x. So I'm just timesing that bracket there by 2. Okay, not every single term. Remember, that's, if you're timesing some numbers together, 4 times 3 times 2, you don't do 4 times 2 and 3 times 2. You just do 4 times 3 and times it by 2. So it could be the same as 8 times 3 or 4 times 6. Yeah, we just times one of them by 2. So 7e to the x, 2 plus 2x, and then I'm going to get e to the 3x minus 2, because I'm also timesing top and bottom by that square root. And then over here, I'm going to get minus 7x e to the 3x times, sorry, not e to the 3x, just e to the x, then times by 3e to the 3x. Because I'm timesing by the square root, it actually just cancels from here. And on the bottom, I've got 2 e to the 3x minus 2 to the 3 over 2. This is not the only way you can do it, but actually I think that's a pretty solid step. Right, now I'm going to factorize out that 7e to the x from the whole of the top. So I will be left with 2 plus 2x e to the 3x minus 2 minus 3x e to the 3x. Then in my final answer, we had e to the 3x semi-factorized within, well, factorized within. So I'm going to expand the bracket. I've got 2e to the 3x minus 4 plus 2x e to the 3x minus 4x minus 3x e to the 3x. Now I'm going to factorize out that e to the 3x, which will give me 2 minus x, because I've got plus 2x and minus 3x. Actually, that was in the final answer, so that's really good. And then minus 4x minus 4. And I think that is how we're asked to leave it. We had plus ax plus b. We found a and b. A is minus 4 and b is minus 4. I don't think we actually have to state them, but I'm going to here. Okay, quite technical that, it's got to be said. I think it's easy to make a mistake, but there we go. Quotient rule, product rule, carefully combining all the terms to get our f dash x. From here, it says, hence show that the x-coordinates of the turning point of the curve are solutions to this equation here. So our derivative is going to equal 0 for the turning point. And it's going to be when the top is 0. You can imagine times in both sides by this, and it just goes. So it must be when the top is 0. You can then divide through by 7 e to the x, because that is always positive. It's actually going to be when this thing is 0. So e to the 3x, 2 minus x, remember then it was minus 4x minus 4 equals 0. And what this question is actually asking me to do is make x the subject of this. Well, not make x the subject, because x is still on the right hand side, but get all our e to the 3x's on one side and x by itself on the other. So I'm going to expand this out. Then I will add x e to the 3x to both sides and 4x to both sides, which gives me 2e to the 3x minus 4. Factorize the x out. And then finally divide through by e to the 3x plus 4. Okay, not too bad. We're then told this equation has two positive roots, alpha and beta, where beta is greater than alpha. A student uses this iteration formula, fixed point iteration, in an attempt to find approximations for alpha and beta. Diagram 1 shows a plot of part of the curve y equals this function and part of the line y equals x. Draw a staircase diagram to show that the iteration formula starting with x1 equals 1 can be used to find an approximation for beta. So here we are, the second point of intersection. Okay, so the fixed point iteration works by us putting a value in for x, and then we find out the value of our function. Okay, that's us putting it into here, the right-hand side. We then get a value out, which becomes our new value of x. That means we're essentially going horizontally along this diagram to our new value. We don't normally draw that line in. Then we just repeat it. Just go up again, find our new value. And you can see if you follow this path, then it is a staircase diagram. Ooh, not that bit there. And it's gonna get to the root beta here. It's only one mark, but I'd probably say, staircase diagram converges to beta. We're then asked to actually use the iteration formula above with x1 equals 1 to find x2 to 3 decimal places. So a good practice here is to just have our starting value, press equals, that stores it as the answer button, and then we're going to type it in, but everywhere there's an xn, we're just going to use answer. So 2e, just do it really carefully, that's what I would advise, 2e to the 3 times answer minus 4 over e to the 3 times answer plus 4. This gives us our next point, 1.5017. 5017, so to 3 decimal places, 1.502. And they also want the value of beta, so for this, we can just keep pressing equals. This is my new answer, so I put it back in. Okay, we're here on the staircase diagram now. Press it back in, I'll go to the next one, and you can just see we're then very, very close. And I can't get any better than that to the number of decimal places I have. So it doesn't take too long to get there, but you can kind of see the process. It's following that staircase. So 1.9675, which becomes 1.968 to 3 decimal places. Finally, using a suitable interval and a suitable function, it should be stated, show that alpha is 0.432 to 3 decimal places. This question doesn't want us to use fixed point iteration again. It's hinting at the sign change rule. What we're going to do is find a function, sub in 0.4315, and then 0.4325, and show that there's a change in sign. So if the function is positive over here and negative over here, or vice versa, and we know it's continuous, then it must be that it goes through the axis somewhere in between. And then that means we're like, as long as it is these values here, then it's going to converge down or towards 0.432 rather than 0.431 or 0.433. So that's why we look at kind of the midpoint between 0.432 and 0.433 and also 0.431. So what we need is a suitable function. In the mark scheme, I didn't actually think to do it like this. They decided to use this and subtract x and then call that the function. So then we're interested in where g of x is equal to 0. That will work absolutely fine. I'm just going to go with what I did. I actually decided to go back to before we'd rearranged it. So this one here. Okay, just as good to show that there's a sign change there. In fact, that's my original function. So just in case I'd made a mistake, this is a very safe one to go for. Okay, look, it'll be equivalent. We'll get slightly different numbers, but it's equivalent process really. So I'm going to let g of x equal this, and then I want to solve g of x equals 0, seek sign change. So g of 0.4315 and g of 0.4325. That's what we're interested in. So I'll type in 0. Rather than having to type it in loads, I'll just do it once. And then again, use the answer button. But I'm not doing it repeatedly this time. It's just as a one-off. We get minus 2.27 times 10 to the minus 3, which is less than 0. Do the same with the other one. 0.4325 answer. Great thing is I can just press up and go back to this formula. Press equals, so I don't have to type the whole thing in again. 7.26 times 10 to the minus 3. and this one's greater than 0. So there's a change of sign, and we should say that g of x is continuous on the interval. It's just exponentials and x's. We're not dividing by anything, like dividing by x or anything. Because 1 over x, you can get a nice sign change going from negative to positive, but actually there's no root. So that's why I have to, make sure this is true. On the interval, do I need to say any more than that? Like what the interval actually is? 0 to 1, I suppose well, the interval is between these. So alpha equals 0.432 to 3 dp, as I explained before, because I'm basically finding these the values at these like midpoints between. Then because it is actually negative here, positive here, we know the sign change is going to be somewhere in between. It's necessarily going to converge to 0.432, well, round to 0.432 to 3 decimal places. All right, not a bad ending to this paper, actually. It's just applying the sign change and iteration, which is actually, I think, a fairly friendly topics once you practice them. The hardest bit is definitely the start, this 5 mark part. I mean, to be fair, that's why it's 5 marks and all the rest are much smaller amounts. Although actually that's 3 marks, to be fair. So yeah, just well done. Very involved differentiation here, but hopefully you understand it and you got it. Keep practicing, that's all I can say, and work very well done.